Unit 5, Relationships in Triangles. Day 1, Mid-segments in Triangles. So here's a few of our vocabulary words. Mid-segment. See the word segment. So it is a segment that joins the midpoints of two sides. So in this case, DE is the mid-segment. Perpendicular bisector. It can be a line, a segment, or array that divides a segment into equal parts, and you must have perpendicular. So it must be perpendicular to a segment, and it must divide a segment into two parts. So take a look at this. The tick marks show that from A to this point in the middle is the same distance from this point in the middle here, and it forms a 90-degree angle. Angle bisector. Look at the markings here. This ray here is an angle bisector. Median. A median is a segment that connects a vertex of a triangle to the median or the middle of the opposite side. So here's the vertex B. Segment goes to the opposite side and splits AC into two equal parts. Altitude. We're used to hearing altitude as the height. A segment that connects the vertex perpendicular to the opposite side. So here is vertex B, drop a perpendicular to the opposite side. Here is some additional vocabulary. You may not hear much, but we definitely want you to hit pause. Go ahead and write in the words and fill in the triangles accordingly. Here we have mid-segment of a triangle. We have mid-segment and we have a mid-segment theorem. So what is a mid-segment of a triangle? It is a segment that connects the midpoints of the two sides of a triangle. So take a look at this. D is the middle of side AB. And E is the middle of side BC. Now, if we connect that, guess what we have? We have a mid-segment. So two sides of a triangle are connected by a mid-segment. In this case, the mid-segment is segment DE. So what is the triangle mid-segment theorem? It says that if we join the midpoints of two sides of a triangle, then the segment is parallel to the third side. So take a look up here at DE. If this is the mid-segment, it's parallel to the third side, so DE and AC are parallel. And guess what? It's half as long. So if AC is 10, then DE is 5. If AC is 20, then DE is 10. So what does the theorem say? It's going to be parallel. The mid-segment is parallel to the third side, and it's also half the length. So here the directions say to identify all pairs of parallel segments. So take a look at XY. XY, segment XY is parallel to the third side, which is parallel to segment QS. So again, segment XY is parallel to segment QS. Let's take a look at segment WY. That segment is parallel to segment QR. So I'm going to write that in. And the last one, segment YW, which is right here, is parallel to the third side, which is segment RS. So number 2, you try. And here you go. So in problem number 3, as we read through, it's telling us that L, M, and N are midpoints of the sides. That's helpful information because if they're the midpoints, then it's going to split the segments into equal parts. So when I look at it and label, P to Q is 40. So P to Q is 40. L to N is 17. And P to R is 46. All right, so what can we conclude? First thing we want to do is we want to see if this whole side is 40, then the two segments are 20 apiece. If this is 46, then this is 23, and this is 23. Well, you want to look to see what's parallel. And so P to R is parallel to L to M. So it's half, which means that this segment right here is 23. Take a look at NM. It's parallel to PQ. So it's going to be half, and that segment is going to be 20. So notice the equal signs here. That means we need a value, a number for an answer. So from L to M, we already got it filled in, 23. From M to N, we have it filled in, it's 20. From Q to R, we don't have it filled in, but let's see what it's parallel to. So QR is parallel to LN. So therefore, this is 17 and this is 17. So how much is the whole segment? You got it. It's 34. How much is M to R? And it's 17. So for the next one, number 4, you try, hit pause, and come back. Did you figure out what perimeter is? Perimeter is the distance around the figure. So you just had to go around and add all the numbers. So here we go. We talked about parallel sides. So the mid segment is definitely parallel to the third side. So where's that? Here's the mid segment. Here's a parallel side. There's a relationship between the two. The third side is twice as long as the mid segment, or we can say the mid segment is half as long as the third side. So what I would like for you to write and remember is that we need 2 mid segments to equal 1 long side. 2 mid segments. So what we want to do to get started, 2 mid segments. So in this case, number 5, we need 2 mid segments. What's the mid segment here? It is 7x. What's the long side? 17x minus 18. So this is 14x is equal to 17x minus 18. We will add 18 to each side, and we have 18 plus 14x is equal to 17x. Subtract 14 on each side, subtract 14 on each side, and we get 18 is equal to 3x. Divide by 3, and x is equal to 6. So let's take a look and see what they asked us to do. They asked us to find x. We plug in 6. We get 7 times 6, which is 42. And then we do 17 times 6 minus 18. And what do we get? You got it, 84. So I would like for you to try number 6. So we set it up, 2 mid segments equal 1 long side. So let's check out which one is the mid segment, this one. So we need 2 of these. 2 times the expression 6x plus 31 is equal to 19x minus 36. Solve for x, and x is 14. So here we just have to make sure we read the directions. In the end, we want the perimeter of triangle JKL is telling us that we have mid segments, which is going to be helpful because there's a relationship between the mid segments and the opposite sides. So we're going to start by working with M to O. Let me highlight it. M to O. So is that a mid segment, or is that the third side, which is the long side? It's a mid segment. And so side MO is parallel to side KL. So MO is parallel to KL. So one is a mid segment and one is the third side. So I need 2 mid segments, which is 6x minus 1, to equal the third side K to L, which is represented by 13x minus 10. Go ahead and solve that and see what you get for x. So you get x is equal to 8. We're going to have to plug that in. Once we plug it in, we find out that this whole side over here is 94. Well, we have this side is 42. What is it parallel to? So this side over here, 42 doubled is 84. So now we know this side is 84. Let's take a look at our other mid segment. From here to here is 49. So what does that mean? That means that this whole side over here is, voila, 98. We're asked to find the perimeter. Perimeter is the distance around the figure. So the perimeter, let's get that written down. So the perimeter is going to be 94 plus 84 plus 98. So the perimeter is 276 units. Keep in mind here that when you look, you see a degree symbol, so we're no longer talking about the sides of the triangle, but we're talking about angles. Well, do we still have a mid-segment? Yes, we do. Well, how do we know that? Because we can see that the middle of one side is connected to the middle of another side, so we do have a mid-segment. If we have mid-segments, we have parallel lines. If we have parallel lines, there's a chance we're going to have corresponding angles. If that is the case, this angle right here is 59 degrees, and therefore angle 4 would be 59 degrees. Okay, so we have 121, which is a linear pair here, so that's 59, or you can look at it as 59 and 59 again is corresponding. We have over here that this angle is 127 degrees, so it is definitely supplementary or linear pair to this angle right here, which is 53. Well, if this angle is 53, then this angle also is 53. Can we find out what this third angle is? Yes, and how? So we have two angles in a triangle. So we add those up plus x, set it equal to 180 because all three angles in a triangle come up to 180. And we find out that x is equal to 68. So we're building on old skills. Those parallel lines cut by transversals, corresponding angles, same side interior, and the triangle angle sum theorem where all the angles inside of a triangle must add up to 180. We're taking a look at number 12, and the first thing we want to do is see, are we talking about angles or are we talking about sides? Well, we're talking about angles. So let's check out our parallel line. So this is a parallel line and this is a parallel line. And so I could clearly see these are corresponding angles. So what I would do is set them equal to each other. 7x plus 4 is equal to 10x minus 11. Go ahead and solve it and see what you get for x. And you get x is equal to 5. All right, take a look at this problem here. Let's see if we're talking about sides or angles. So we're talking about angles. So what are we going to use? The fact that we have parallel lines, and let's figure out what the angle pair relationship is. Well, those are corresponding. So what do we do when angles are corresponding? We set them equal to each other. So let's go ahead and set it equal to each other. Let's solve. Let's see what we get for x. We get x is equal to 9, but we're not done. Take a look at this. It says find the measure of angle CBF. So C to B to F. Remember, we always want to concentrate on the letter in the middle. So if we go from C to B to F, what we're really doing is we're concentrating on this angle in here. So what we're going to do is we're going to take 9, multiply it by 9, that's substitution, because 9x plus 2 is equal to that answer. So I have 81 plus 2, and therefore that angle is 83 degrees. So just make sure you read the directions very carefully. We left some problems for you to do, and good luck.